Hello and welcome to my Tech Fun. My name is Igor, and in this video I would like to compare two most popular 3D printers in the world. And one is the Creality Ender 3, well this is the V2, and the Prusa MK3s. In my latest poll on very popular Facebook page, I found out that these two printers are the most popular in that group and probably in the world, and with a reason. And since I published the video about assembling a review of this Ender 3 V2, a lot of friends who know that I already have a Prusa MK3 ask about the difference between these two printers. Of course, the price difference is huge, similar to fight Connor versus Mountain, so huge difference in the weight. But if we would have two Connors, that maybe the situation will be completely different, right? So that's what we will do here. I will include in the price at the final score, so that's why I think I can compare these two printers. Here is my specification table, which will be uploaded to my website because I'm sure that somebody would have some new suggestions, and I can upload that table, which will be on my website. I cannot change this table, which I prepared already now. Let's start with the price. In US dollar, the Prusa MK3 is $999 if you buy an assembled printer, and if you buy a kit, then it costs $749. I mean, that kit is in so many parts that, for example, I needed 10 hours to put this together. It's very fun and it's useful because with that you can actually learn better your printer, and you know if you have a clog in a hotend or how to disassemble the extruder or similar. The Ender 3 price is $260, and it can be assembled in maybe 1 hour, for example. So much easier to assemble compared to the Prusa if you buy a kit. 3D printing area, which is one of the most important parameters for printers, is for Prusa 25 by 21 by 21 millimeters. So here I have 25 millimeters. On Ender 3 it is 22 by 22 by 25 millimeters. So we have a higher Z-axis here. For me personally, I mostly print technical parts, and usually I try to design them or print them in mostly horizontal positions. So for me, bigger XY area is more useful, but it depends of your objects which you will print. At the first look, the first impression when I see a lot of plastic parts here on Prusa MK3. And I was very worried when I saw that even many main important parts like a Y-axis holded by plastic parts and held by zip ties. But it works, but I don't know, so the first feeling was that how can this work? Most of the mechanics is based on linear rails and linear ball bearings, until the Ender 3 is based on these V-slot aluminum extrusions and these wheels. And the movement in both cases is based with these timing belts. So for me, as a mechanical engineer, I better like full metallic parts, and for the movement, these wheels of course are not metallic. I'm not sure how that were. I had this only for the short period, the Ender 3. But of course linear bearings will wear too, but I believe they will last longer. We will see. And there is interesting difference in the homing. The Ender 3 is based on these limit switches. There are 3 for each axis, and where they are pressed, then it's detected that it's in home position. With the Prusa, there are no limit switches. I'm not 100% about this, so it would be good if I would get the confirmation, but these TMC 2208 stepper motor drivers, which are also included now in this V2 in Ender, they have the function that they can recognize if the signal is step signal is sent, but the stepping doesn't happen. So it's using this function for crash detection, for example, or probably it used to detect the homing position. When it moves to the complete edge, it probably recognizes that it cannot go further, and it's probably how that's the homing happens. I'm not 100% sure about this. But of course, that's only for X and Y axis. The Z-axis is based on this pinda probe sensor on the side, which is also used for the calibration of the bed. Okay, let's start step by step. The y-axis. So the y-axis here on Prusa has two 8mm rods, and of course one timing belt and one NEMA 17 stepper motor. The timing belt is solved by these two screws, which is not perfect solution, for example, but it works, and you have to adjust it very rarely. The Ender 3 is moving now on this V-slot aluminum, but it is improved now. It is 40 by 40 millimeters aluminum extrusion, and it is better, it is stronger, but not because of the aluminum extruder, but the distance between wears is bigger, so that's why this gives more stability compared to the V1. And the moving is also same by NEMA 17 stepper motor and the timing belt, but the tension is much easier to solve because we have here in V2 very nice improvement that rotating this wheel we can change the tension of this timing belt. That's very nice solution, but as I mentioned that you have to do very rarely, so I'm fine with this solution too. The x-axis moves in this direction, here and here, and of course here again it's more visible. On Prusa we have these 8mm metal rods, and you cannot see behind we have three linear ball bearings, and of course here the movement is with this also the timing belt, and here this stepper motor. On Prusa the timing of the x-axis has to be done with these three screws, and this is just another screw to secure the position of the complete stepper motor and this holder. And unfortunately I think this is the weakest point of this design, and I saw several pictures in the Prusa Facebook group where here this part broke. You can print it yourself, these are 3D printed plastic parts from PETG, but I would be more happy if they would be a little bit stronger, maybe for injection molding, or at least this part from aluminium. On Ender 3, again we have 20 by 20 mm alloy extrusion, and of course the V-slot, and this NEMA stepper motor which moves it's on the other side, which moves the hotend with these timing belts. And of course here the tension is very good solved, that we can change the tension by rotating this. Now this is also new, as I mentioned, in V2 compared to the V1. The Z-axis. Now here I believe that we have a very big difference, because Z-axis on a Prusa printer is led by these two 8mm metallic rods, and the movement is by two stepper motors and two 8mm trapezoidal screws here and here. This means that it will definitely move parallel, so we don't have that kind of problem, which I believe this is the biggest weakness with the Ender 3, V1 or V2 both cases, that the support you cannot see from here, but it's here on the other side. We have only one stepper motor and one 8mm rod, which is not a problem. Stepper motor can handle this weight, but it's only supported on one side. Here we have this passive block holder on the Z-axis, and I can move it by hand, even if I tight it correctly. I know I tight it correctly, I measure it, but I measure more than 0.1 mm of moving if I just move it with my hand. Usually it's caused by gravity, but I imagine if the hotend is here, maybe it gives more weight to it, and maybe it will be a little bit lower. If it is constant angle, it's not big difference, because you will level the bed to be parallel with the movement path of the nozzle, but it may be a problem if you print something bigger, and this square here, if this is not under 90-degree angle, then the printed object will not be correct in the 90-degree angle. So this is what gives me in Z-axis more accuracy with the Prusa, with this angle between XY flat and Z-axis, the vertical surface. Maximum travel speed is, according to specification, more than 200 mm per second with the Prusa and 180 mm per second with the Ender 3, that's not big difference here. Now extruder, again very big difference. With the Prusa we have a direct drive, which means the extruder stepper motor and gears which moves the filament is mounted on this moving head above the hotend. This is good because very short way between extruder and the hotend, and this, for example, gives me a big advantage with the retraction speed is much shorter, the reaction, and very big difference maybe with TPU, with flexible filaments. And of course a shorter TPU, Teflon tube, gives smaller possibility for the clog inside the Teflon tube, the filament, if it is not so accurate. And as I mentioned, in my practice I noticed even with the PLA or PETG the biggest difference in retraction. So I have much more stringing, because there is one small disadvantage with direct drive, that its bigger mass is mounted here on the extruder head actually, and this moves. This may result in more vibration, for example, and you may see more ghosting if you print with higher speed. But it's really rigid. This frame is very strong in this direction, so I didn't notice that it is disadvantage in this case Prusa compared to the Ender 3. The nozzle. Of course, both cases we get 0.4 mm nozzle, and we can heat it up. Maximum temperature according to specification is 300 degrees Celsius with the Prusa, and 255 degrees Celsius with the Ender 3. Now this is significant difference, and it is important if you print other things than PLA or PETG. So if you want to print maybe ABS, ASA or maybe nylon, in that case, but you cannot do it with the Ender 3. It requires higher temperature. According to specification, the Ender 3 writes that it can print PLA, TPU and PETG. I don't have too much success with the TPU because of this boulder extruder. According to specifications of the Prusa, it says any thermoplastic including nylon and polycarbonate, and I can confirm that I print PETG, PLA, ABS, ASA, nylon, TPU successfully on the Prusa Mark III. Okay, a few words about hotbed. Hotbed temperature, again according to specification, the maximum for Prusa is 120 degrees Celsius, and according to specification it is 100 degrees Celsius on Ender 3. But actually I can set it up to 110, but it's not recommended to use it on that temperature. And again, this is very useful if you want to print ASA or nylon. For ASA, I could only have successful prints on at least 110 degrees Celsius on printing bed. And of course you will need enclosure if you want to print some higher objects. Hotbed type. With Ender 3 we have this new textile glass, and it's very good. It's good improvement compared to the V1, because the objects, the PLA, especially the PLA, the PETG also, sticks to it very good, and when it cools down it will almost pop up itself. Of course this will be a disadvantage in case that you run out of the power. Theoretically both printers can resume the printing, but if the bed cools down the object will be removed. It is true in both cases. Of course you can use some stick to prevent this, but usually I'm not prepared to lose the power during the printing. With Prusa I'm using textured flexible PEI sheet, but I have also a smooth one for better adhesion if I need. Bed leveling, now huge difference. The Prusa has automatic calibration on 9 points based on this pin-down sensor, which you can recognize very easily. With the Ender 3 you have to do it manually, level the bed with these screws and knobs on the bottom. Now this is not a problem. You can do it once and you don't have to do it so common. How often you have to do it? I'm not sure if you are familiar with that joke. The man enters into a very huge building and asks the doorman, do they change regularly cables on the elevator? And the answer was that Yes, of course, regularly after every accident. So you should check the bed level a little bit more often, not only after failed prints. As I mentioned, it's not so important, you don't have to do it very often. But with the Prusa, this bed has this plate sheet. Now it's this texture on it, but I also have a smooth one, and I can easily replace it. And they have different thickness, and in the software I can change so-called live Z on different plates, and that's very easily done. In the Ender 3, so far I don't have this problem because I only have this glass to print on it, but if you want to change more often the printing surface, in that case after every change you have to level the bed. So if you are changing the plate too often, then definitely this is very big advantage to have this automatic calibration with the Prusa. Again, one information from the website, layer thickness is between 0.05 and 0.35 on Prusa, and between 0.1 and 0.4 millimeter on Ender 3. I don't recommend 0.4 millimeters, but like, yes, if you have a bigger nozzle, but with a standard nozzle it's too much. Now, usually I don't print with 0.01 layer thickness because it will be very slow. Now, that can be useful if you are using so-called variable layer height. For example, if you print a sphere, and the top of the sphere, if you are using too big layer height, that will be very visible. And in a Prusa slicer, for example, probably it's in Cura, I don't have too many experience there, you can set that on top of sphere, reduce the layer height, even go to the 0.05 for example, and in that case you can print those spheres quite quickly, and where it will be very visible on the top of the sphere you can use smaller layer height. So in that case your printing time will not be extended too much. So very useful feature to have smaller layer thickness even if you don't use it for the most of the objects which is printed. User interface and display. Now Prusa has this mono display texture display in, I think it's 20 by 4 lines, 20 characters, and it has this rotating knob, which is, I don't know which rotary encoder they use, but it's not too accurate. So I noticed that sometimes I feel that it moves only one step, but actually it moves two, or maybe I move 2 steps and it moves only one. So I have to pay attention, especially when I start some new printing. So I had some problems that accidentally it started to move an object lower. With Ender 3, this new display, color display, and this knob is fantastic. So this is huge improvement, I believe, compared to the V1. I almost missing some games on it to play with this knob and this display, and it gives me the feeling that it's almost touch display. Several times I try to press the button on the screen. Unfortunately it's not touch display, but it gives that feeling, so it's perfectly. Of course this is only more a design, because you are using this, make the settings, and then the printing is working by itself. So I'm perfectly happy with this display, but I really mind with this rotary encoder, this knob is not that accurate. So I have to pay attention which point is selected from the menu. In both cases they use the TMC 2288 stepper motor, and this TMC stepper motor are very silent. So that's huge improvement compared to the V1 on this V2 Ender. And that's really true. I hardly can hear, actually I cannot hear the working of the stepper motor. So, because I'm not sure if you are familiar that older drivers, that A something, I don't remember, gives that very high frequency sound, which is really annoying, especially if you are working next to it. So definitely, in that case, if you are working next to it, the V2 is better option compared to the V1. But of course, we are comparing these two printers. Both cases, they have that silent stepper motor. But somehow, the fans are much quieter on Prusa. I have this almost 2 years now with me, and it's my working room. Next to me, only maybe 2 meters. And I can work, I can even phone and make a conference next to it. It's really quiet, even the fans. But the fans on Ender 3 V2 are quite loud. Of course, that's not annoying with like high frequency sound of the stepper motors, older version, but it is still, I can see a lot of possibility for improvement to have some silent fans. Not only this fan for hot end or part cooling, but also for the electricity properly. There is also a fan, and it's also very loud. I noticed that a part cooling, maybe stronger fan, a little bit better on Ender 3 compared to the Prusa. I had some problem with the Prusa when I have a very big overhang on behind, and the airflowing is not so good. So from behind it's not so good cooled. Both have resume printing function, as I mentioned, if the power goes off. With the Prusa, which I like, we have this bigger SD card, and with Ender 3 we have this smaller SD card. It's a little bit more comfortable to use this bigger one, but it's not a big problem because you can press it, switch it, and we have provided this USB converter, so we can use it easier with the computers. And now let's talk about printing. Always one of the first objects which I print is the 2 centimeter calibration cube to see the accuracy of X, Y, Z axis, and in both cases they are almost perfect, so below 0.1 millimeter is the accuracy in both cases. The next object is always a benchy. The benchy printed on Prusa looks better compared to the Ender 3 benchy, but the biggest difference is I noticed some spots which can be easily removed even with my nails or my hand, and some more stringing. Now I printed both using the same filament and the same temperature, and I believe that this bigger stringing is because of the slower retraction speed because of this Bowden drive compared to the direct drive on the Prusa. Otherwise overhang were perfect, bridging is also good, so surface is a little bit more better constant with the Prusa compared to the Ender 3, but I noticed because the driving of the filament from the spool to the extruder, it's shorter and it's easier, but here I have that bigger angle, but I will print, there is a very good upgrade which you can print yourself, a holder for filament here to give it better angle to go into the extruder, so it doesn't have so big tension to pull when it's big angle, especially with the smaller diameter of the spool. Now, next object I printed are these test specimens. They are printed in horizontal and vertical position. These green are in PLA. I noticed a lot of stringing because I printed them on both on 210 degrees Celsius. I noticed I get much better quality, less stringing, if I print it on 200 degrees Celsius with Ender 3. But I want to use the same temperature because I want to break them to see is there any difference, especially these printed in vertical position, to see the layer adhesion. And yes, I have safer method to do this test, but I don't expect too big loads here, and this is much quicker. Stronger than I thought. Prusa PLA, let's do. Safety first. And these are the results. It looks like I have to print PETG on higher temperatures, but why is so big difference on PLA specimens? I'm not sure. Maybe because of first printing quality on Ender 3, there must be some weaker layers. So far with Ender 3 I could print I could print ASA, but of course you will need enclosure if you want to print higher object than this one. With TPU, I tried once, I didn't have a success. I have to see what can I change it. With Prusa, I can regularly print ASA, even nylon, but also I printed several times the TPU. And now the final conclusions. As I mentioned, this table will be uploaded to my website, so I can update it if you give me good suggestions what to change in it. And which one to buy? So don't forget, on this price you can buy 2 of these, and one of them you can do some upgrades, like to have a direct drive. Now if you will print mostly PLA and sometimes PETG, in that case the Ender 3 will do the job. The quality is not so good with the Prusa. It is hard to make mistakes, and it gives me better constantly better surface and better print quality. So if you are doing a service, 3D printing service for other people, and they said, oh, I get this from other company much better, in that case again Ender 3 will not be so good compared to the Prusa. But if you need capacity, imagine for this price you can buy 3 Ender 3s, and they will do the job much faster, of course, because we have 3 machines. If the printing quality is very important and you want to print TPU, nylon, ASA, ABS, then definitely the Prusa is the printer if we have to choose between these 2. I hope this video was useful to you. I have in plan several things to test with these 2 machines. One of them is the power consumption, which I already mentioned with Ender 3, but I want to do some more experimenting here. It will be published here on this channel. I hope this was useful to you. Thank you for watching and happy printing. Bye.